Hi folks. So it's about 11:30 in the Netherlands, so 11:30, and I still had my telescope up from yesterday to show you the Venus Jupiter conjunction, and we have a clear day in the Netherlands, so I wanted to show you the sun. So I don't know if anyone is able to join me because it's still morning here in the Netherlands. So let's see what happens. Anyway, I'm looking at the sun, so I'll wait until a couple of persons are joining the stream. So there's one person, Derek. Hello, Derek. We're looking at a live view of the sun from my rooftop observatory. Well, I don't have an observatory, but I do have a rooftop. And yeah. So obviously there's one enormous sunspot here, or like a combination of sunspots. You can see it on the right here. So maybe we can go there and zoom in a little bit. So, and this is my 80 millimeter, like 500 millimeter focal length refractor telescope I'm using with a solar filter. And like these sun filters, they are pretty cheap to get. Will cost you $50 to $100, something like that. And you put it in front of your telescope, and you get this kind of view. So it's pretty cool. Sorry, I should stay away from that coffee. So let's see if we can zoom in a little bit. So this is obviously the biggest area where a huge combination of sunspots are active. Can I zoom in a little bit? Let's try to do that. Maybe it's this. Here it is. So pretty cool to watch. So it's on the upper right side of the sun. And I see a couple of people more. Andre Vanji, Sirius. Hi guys or girls. I assume guys. Welcome to the stream. Thanks for joining. We are watching the sun, and this is obviously the biggest sunspot. Yeah, if you have any questions, feel free to ask them. It's still early in the morning for most for those of you in the US, I think. So it's almost noon here in the Netherlands. So let's zoom in a little bit more. It's very interesting. Maybe I can magnify it a bit for you. I'm still a little bit. I didn't sleep that well. I was up all night trying to test some new gear. So I'm testing also this new mount. This you can see it here, ASI AM5 mount. It's performing pretty well. So here we have it, the sunspot here. This is a huge one, right? Can you see it? Hope you can. So this thing I read on, you have Space Weather Live. That's a good site you can use to look up all kinds of information. So spaceweatherlive.com. And obviously they name all these sunspots, and this particular area is has the interesting name 3234. And when I'm looking at the data here, so 3234, it has 25 sunspots apparently, and a size of 860. Well, as a comparison, if you would like project the Earth onto the sun, that would have a size of 170 according to that spaceweatherlive.com information. So this is about 5 times the size of the Earth we see here. And I don't know if that's just this particular sunspot here on the top right, or it's all the combination of sunspots we see here together. So yeah, it's like a Sonder. Yeah, that's what I'm trying to find out indeed. So it's about 5 times the size of the Earth here. Oh, a little bit shaky. Do you think these observations can help predict auroras? Yeah, definitely. So earlier, or like I think like a couple of days ago, we had a huge aurora. It was visible even in the north of the Netherlands, and that happens very rarely. So, and they actually were able to predict that aurora from this particular area. That's also why I'm interested in looking at this. And yeah, what they do, they have a special telescope in space, like that's the Dynamic Solar Observatory of NASA, and they are able to like track all the solar flares and the sunspots, and especially around those sunspot especially around those sunspot regions you can see here. From time to time there are massive solar flares and what they call coronal mass ejections, if I'm correct. So that means that sometimes the sun releases a huge amount of plasma, and then it takes that plasma a couple of days, if I'm correct, to actually travel from the sun to the Earth. And so when they see this coronal mass ejection, they have a specific way of measuring when it happens, the speed of that plasma moving towards Earth, so they can predict, yeah, like the northern lights we call it, or the aurora we would see on the Earth, and particularly also for safety, they keep track of these things because it could like harm radio signals and radio traffic on Earth, and yeah, so very interesting also to look into that. So I'm only an amateur with a telescope watching solar sunspots, but yeah, it was really interesting to see to read up on that. And yeah, what I want to do in this stream is actually I want to take a short tour of the sun, like I'm doing now with this solar filter, but I also have a hydrogen alpha filter. And with a hydrogen alpha filter, we could look at those sunspots in a much more detailed way. So that's what I'm going to do. I'm just going to take a tour with a regular solar filter so you can see what kind of views you could get with a regular telescope and a solar filter that isn't that expensive to buy. Then I'm going to show you a view with the Daystar Quark. I did a couple of those streams before, but so you can see the difference between the different setups you could use to look at the sun with your backyard telescope, basically. And of course, never look directly at the sun. That's always a bad idea. So okay, this is obviously the biggest one. Let's zoom out a bit, and let's check if there are other sunspots active. So if you have a solar filter, you can see these kind of sunspots. And maybe if I'm overexposing this, let's try that. Here we go. So how are you doing? Greatly enjoying your videos. Keep up the great work. Thank you, Dan. I assume you're also from the Netherlands, so you don't have any difficulty understanding my accent, my Dutch English. So no, you can't really, right? I'm trying to overexpose deliberately the sun to see if I can look at solar flares on the edge of the sun, but with this kind of filter you cannot, because you can see here there's a bright white disk, which is the sun, of course, but I don't see any solar flares. So you do need a special hydrogen alpha filter, they call it, or hydrogen alpha setup, or even a solar telescope with a special filter to actually see these solar flares. So that's what we are going to do in a minute, or now maybe in 10-15 minutes. So we have two little ones there on the bottom. Let's try to check them also. And let's see how big they are. So this is actually about The top right one is about 5 times the size of the Earth at the moment. That's really incredible. But here we have a couple of smaller ones at the bottom. Let's see. So hey guys, thanks for joining. Yeah, really big. Sander, you're also from the Netherlands or Belgium? Yeah, let's see. Okay, let's zoom in on this smaller one. I'm actually not zooming in physically, but I'm just taking a smaller field of an area, region of interest, they call it. And it looks like zooming in. So can you see it? I think so. So we have 2 smaller ones here at the bottom. So let me check out the size of those. And what they are called. They have a very... I don't see them actually. Oh, I think it's 3238 and 3239. Okay, 3238 and 3239. They are obviously smaller. So let's see, 30. Okay, these 2 are about half the size of the Earth, if I'm interpreting the data I'm looking at here correctly. So again, I'm looking at spaceweatherlive.com if you're interested in checking out all the data there is on these active solar spot regions. So 3238 and 3226. 3236 is 80 and 70. So yeah, that's about half the size of the Earth. These 2 minor sunspots, we would call it, but yeah, actually they are pretty big. Okay, so that's interesting, I think. For me, at least. So let me recenter that sun. And I do want to show you, like, also the H alpha view, but it will take me maybe a couple of minutes to set that up. So yeah, I hope you want to stay for like 4 or 5 minutes because it takes a while to get that H alpha filter installed and to refocus my telescope. And yeah, actually, if you have any questions, let's see. Fellow Dutchie, Dan. Yes, Dan, I am using the Daystar Quark chromosphere. So that's a particular filter with some kind of mechanism, also some kind of cooling mechanism, I think. And it allows you to look specifically at the sun in the H alpha wavelength. So that's exactly, I think it's 656, if I'm correct, nanometers. And at that very specific wavelength, you can actually see the granulation more of the sun and yeah, solar flares and everything. So that is pretty cool, but it takes some effort to install that. So I will be gone for a couple of minutes to do that. Yeah, so Andre, that's what I'm trying to say here. So what I'm using right now is a relatively inexpensive solar filter. So I have an 80mm aperture telescope right now I'm using, and there's just a solar filter in front of that telescope, and yeah, it costs you about, I think I paid about 50, maybe 50 to 100 euros. I'm not sure exactly what it was, but yeah, relatively cheap. So that's a very good solution. You just put that that filter in front of the telescope, and then it of course it blocks out most of the energy of the sun, and you are then able to see all the sunspots that are on the sun. And what I like about this view is that we have this overview now. I can see the entire disk, and when I install the H alpha, you will see it in a minute or two. Maybe 10. You will see that we have, it also magnifies the view of the sun a lot. So together with the camera I'm using, that will give you like a quarter of the sun in the field of view. And that's pretty cool because you can then see all kinds of solar flares and a more detailed view of those sunspot regions and the activity around those sunspots. But I also like this. Like I can almost catch the entire sun in the field of view with this camera, so that's also nice to see. Have you ever heard of audiobook? Solar Flare by Larry Burkett. It's an awesome, but only on cassette. Okay, that's a good tip. I will check it out. I didn't listen to that yet. So, guys, I will put up a bit of music. Sorry, I'm a little bit having a little bit of a cold. Let's see. Um, is this actually playing? I don't think so. Now, anyway, no music. But I'm going to change the view here. Saludos, Mexico. ¿Cómo estás? Paranormal. Okay. So I'm going to change to the H alpha filter. I'm going to show you that setup in a couple of minutes. So bear with me, and I'll be back. So let's see if we can get a clear view now. I think I still have to refocus a little bit. Oh, it's pretty cold outside. The other way around. Okay, so let's reduce the exposure time here. It's okay. We see something at least. Let's go back. So I did twist the camera a little bit, so now I'm not sure if the sunspots are still in the same position. Let's see, let's put the gain a bit up. So you can see more granulation now from the sun. And sometimes it's also nice, at least I like it, to get a like this black and white view of the sun. Let's see if we can find that big, I think this is the big solar region here. The sunspot region I was showing you earlier on. So it's now on the bottom. So can I... Yeah, I think this is about the best I can get. So you can see it, maybe I can focus a little bit better. I think this is about as good as it gets, but... So now you can see more activity on the sun. Can also stretch it a little bit. So I'm going back up and I'm going to try and get this this particular sunspot region as sharp as possible. Alright folks, this is about as good as it gets. So this is, I think, the most massive sunspot region again. So let's take another tour of the sun now. And before maybe I can also stretch this. So here you have a little bit of a better idea what's going on. So this is the Daystar Core chromosphere filter. Not the cheapest one, but it will give you this more detailed view of the chromosphere of the sun. And a lot of activity is going on that in that particular area of the sun. So that's also pretty cool to do. And yeah, as said before, this is the sunspot region. This also caused a coronal mass ejection earlier on this week that caused a beautiful aurora that could be seen all the way to the Netherlands and England and probably also Canada and everything. So anyway, I'll try to get the chat back. Chat, where are you? So guys, 11 folks watching. It's still early on in the morning, so but I wanted to do this live stream anyway. So pretty cool, I think, to see. It's a little bit shaky, the image, because we are zoomed in. We are, yeah, like, I think at 2000 millimeters zoomed in. So all the vibrations you're seeing right now, this is also due to the atmospheric turbulence in the air. The sun is pretty high up in the sky right now, but it's still March here in the Netherlands, and I'm at 52 degrees latitude. So it takes a bit of, yeah, so like I still have to go through a lot of atmosphere. I'm actually curious what kind of views I could get in the summertime. Anyway, so let's take a tour here. So maybe we can look at the edge of the disk first and up the gain a little bit to see if there are any solar flares on the edge of the sun. I see a small one here. So this is also the difference with the chromosphere, the Daystar Core chromosphere, or the H-alpha filter I'm using. You can actually see these little filaments, they called, I think, solar flares lingering on the edge of the solar, on the sun disk, on the sun's disk. Okay. Anyway, pretty cool to watch. So maybe get this a bit out of the way. So let's see if we can. Oh wait, I can also, I think, control it from here. Oh no! Oh, what did I do? Oh, that was stupid. I think the tracking rate is, yeah, the tracking rate is very fast. Sorry about that. Let's try to get the sun back in the field of view. This way. Here we go. Maybe a bit faster. Like this. Now, I don't see any flaring here. Maybe here. I think we started here, right? Let's see. Trying to get my bearings here. So up is down. Down is up. Okay, left is right and right is left. So everything is different. Okay. So here we have a small solar flare. Can we... Here we see it. It's not very big, but definitely one. Oh, no. I wanted to use this. So you can see the sun. Can you see it actually? I hope so. Yeah, you can. So let's go down a bit. Down. Oh, up is down. Up is down. Left is right. Right is left. Okay. Here we have another one. It's small, but it's definitely visible. So up the gain a little bit again to show you that flare. It's very faint, this one. But you can see it over here. Something happened. Oh, okay. Let's go down. I'm always curious. Sometimes you're lucky and you see a big outburst. Small solar flares here, lingering on. Very nice. So this is the chromosphere view of the sun with an H-alpha filter. Not a lot of flaring. We have a brighter one. Yep. Definitely visible. Look at that. This is more, then now we're talking. This is pretty cool. So can we actually reduce the brightness a bit? It's always difficult. You can't. Either you have to overexpose to see the flares, or underexpose, or expose less to see the chromosphere of the sun. Ah, pretty nice flares here. Tidal is in the house. Hello, Tidal. We have Andre. There's a plume visible on the top right. Oh shit! I missed your messages. Sorry about that. So yeah, we have a couple of flares here. So always exciting to see them. And some of these flares, they only last for about 30 minutes, but others they can linger on for days. Oh. Well, here we have a very minor ones, and I think a sunspot here. Maybe new sunspot that is developing right now. Let's see, yeah, it's a small one, definitely visible here. And you see also this kind of thing. I think this is also a flare, but that solar flare is in front of the sun, so we can only see like the shadow of that flare. And I think the most beautiful images you can get is when you have a solar flare on the edge of the sun, and then it bursts out into the blackness of space, and then you can really capture it nicely with your camera. But anyway, let's move on. Let's go up. We have another one. So this has a specific name, which I forgot, of course. So we have this bow here. Pretty cool. Alrighty. Let's see. What do we have? So now we're back to where we started. So these are the minor solar flares on top of the sun, or at least the top as positioned by my camera. So I do want to go back to that active sunspot region. See if we can find it again. Should lower the exposure a little bit. Zoof. Is it here? Yeah, this is it. This is it. This is the most active region, I think. Yeah, it's the other way around. So this is what we're looking at when I was using a regular sun filter in front of. So I'm using this one. Can you see it? I don't know. Where's my? If I put it in front of my head, probably. So this is a Bader solar filter for an 80mm aperture telescope. It has these strips and these, like, what is it? Like connecting points. So you can just put it in front of your telescope, before your telescope. And yeah, it basically blocks a lot of the energy of the sun. And then you can see the sunspots. And with an H alpha, like the Daystar chromosphere filter or a similar filter I'm using right now, you can actually look at a more detailed, you get this more detailed picture of the sun. So I can maybe stretch it a little bit more. Let's see. Pretty cool to watch. I think I'm going to take a couple of videos. So what we are usually doing is people who are watching the sun, they take a couple of videos and then they stack all of these individual frames to get a clearer picture of the sun. And actually, the higher your frame rate per second is, the better your results. Because you end up with more frames. Let me... Oh, I did something wrong here. What is my hardware? I wanted to see where I'm saving my images. Because I have an external hard disk connected to a mini PC. So maybe I can use that. I know it's a little bit faster than the hard disk on that PC. Astrophotography, and we are going to call this Sun 0323. Very cool name. Okay, apply. Okay. Let's see. So my frame rate is not that good. So maybe I can go down with the exposure a bit and then up the gain. Now I'm still only at, so this gives me a more grainy picture. Nah, that's not what I want. I think it's just, now I keep the gain to about half, 50%. Oh. And then the exposure. Oh yeah, what I can do is 2 times, of course. Let's see if that helps. Yeah. So I have the ASI 678. That's it has a, yeah, for those of you who are in the business of astrophotography, it has a small pixel size of only 2 mu or something like that. So I can like do some binning here, and that gets me to like 50 frames per second. Which is better too, because I now, if I'm going to capture a 1-minute video of the sun, so 50 frames per second times 60, I will end up with about 3000 frames, and that's of course cool, because then you can look at which frames are the highest quality frames, and you can stack those frames. Anyway, so let's also look at my histogram. Maybe a little bit extra gain here. Something like this. Now, it's still shaking a lot due to the atmospheric turbulence. Let's go up. Let's try to find the center here. So we have some circles. Let's put it in the center, that big spot. So again, this area is about 7 times the size of Earth, which is pretty amazing. Right, let's kill the rectangle. And yeah, start capture. The target is definitely the sun, or maybe the sunspot. And I want a time limit, a 1-minute video, and I'm just going to start it. So here we go. And oh, no. Stop. Stop the capture. The output format, I'm always using SCR. I forgot to change it. So now I have a lot of pictures, but SCR or AVI will give you a video file of the sun, and that file can be processed further. So I'm taking a 1-minute video here. So here we go. So guys, you don't have any questions? You have 14 people. That's still early, 12 o'clock. Here it's noon in the Netherlands. A lot of people are working, of course. I thought it's bright. We have some clear skies, so let's show you this view. So yeah, frames are pretty good. 46 frames per second. I'm happy with that. So you can see here I'd captured already 2000 frames, and we still have 10 seconds to go. 10, 9, 8, 7. Okay, so I'm ending up with more or less 2500 frames, or a little bit more even. That's okay. So is anything happening here? You see these bright areas, right? I think those areas can actually produce some solar flares as well. So most of the solar flares are, most likely the solar flares will erupt from these sunspot regions on the sun. Let's see, can we stretch it here? It's a pretty cool image when you stretch it. You can also put it in negative. So black is white, white is black. Also pretty interesting. And of course we can look at it in color. But for some reason I don't like it. A lot of people like the colored view of the sun. And I do like the grayscale image more because I can see more details. But it's pretty cool as well. So you can see here, we're only looking at the sun in a very specific wavelength. So in the red part of the spectrum, basically. We can also do like a... Ooh! Always try to play around with this. Maybe when I stretch the image. No, 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 no. That's not what I want. I think this is the best we can get right now. Yeah, it's a bit shaky. Is this the... Yeah, this is the biggest view we have. Okay. So let's see here. Hello, Vito. Are you using the AM5 to explore the sun? Yes, I am. Abdullah. So here you can see it. I'm connected with the ASI mount via ASCOM. I have tested it for a couple of nights now, 2 or 3 nights. And I'm happy to see that the ASCOM server or the ASCOM driver works. So yeah, I'm pretty happy with the mount so far. It tracks below 1 arc second per pixel. So that's pretty cool. And super lightweight, of course. So my first impressions are pretty positive. Now, of course, it's an expensive mount if you compare it to like the beginner mounts you can also buy. The normal equatorial, the belt drive and like the normal gear drives. So this is an harmonic drive mount. So I will be putting out a complete review. I have to put all my experiences on a text in a text file, and then I will like give you an organized review of what I think of the AM5 mount. And but so far I'm liking it, especially because it's so lightweight and you can travel very easily. You can pick it up and travel anywhere, and it comes with, or at least I bought a carbon fiber tripod with that mount. And because I think the main advantage of those harmonic drive mounts is that they are portable and you can carry them around. Yeah, so that's what I'm doing with that thing. Raw. Oh no. So maybe I will show you the colorized version here. Maybe for a live stream it's nicer to show you the colorized image of the sun. So once again, this is the biggest sunspot, about 7 times the size of Earth, and it caused a big coronal mass ejection earlier on, I think like a week ago. And yeah, we actually saw, because of that coronal mass ejection, a lot of plasma was moving towards Earth, and we could actually see the northern lights, so the aurora, like the green lights at night, in the Netherlands. And that's very, very rarely happens. And that also means that the coronal mass ejection was pretty heavy. Anyway. Okay. Let's see if we can see something more. Some other sunspots. Let's take another tour of the sun. So I said before, we have a couple of bright flares. I see one here. I think this is also, if we compare it to the size of that sunspot region, which is 7 times the size of Earth, this would definitely be 1 or 2 sizes, this flare we are looking at. So yeah, the sun is huge. A lot of here we have on something. What do we see here? Yeah. So like these things here. So these, like these shadows you see on the sun. So I think they are also partly solar flares. But because we are looking right at the sun, they appear as these shadows on the disk of the sun. Let's go a bit further here. New. Yeah, a little small flare over here. So guys, how are you doing? So this is again, I think this is also a solar flare. But it's hanging in front of the disk of the sun. On the left here. Whoa. Oh, here's something going on, right? What is this? I think it's like an outburst. Let's see. Here. No, I'm pressing all the wrong buttons again. Oh, here. What's that? Can you see it? It's like very small in the middle. Can I... Maybe I can stretch it a bit. Here. This is something peculiar. I put it in black and white maybe. Can it be here? This is brighter than the rest of the surface area, so could be an ejection of some kind. Maybe I'm wrong, but definitely looks like it's an active region. I'm going to capture it. It's kind of interesting. Let's do a 1 minute video again. It is strange. So if you want to do like a time-lapse video, that is also possible, but some of these solar flares, they last for half an hour or an hour or 1.5, so you would have to take like videos once every 1 or 2 or 3 minutes to see the development, like the change in that particular region over time. You could also watch it and see what happens. It would be cool to see a solar flare erupting. Maybe I'm wrong, but it looks a bit like there's an eruption happening or going on here on the disk. What do you think? So put it in color again. It's a bit overexposed now. Here, this particular part. And this is, I think, a solar flare. So this shadow here on the sun. That's a solar flare hanging in front of the sun. And this is also interesting. I think another solar flare. Okay. I should invite an expert on the sun to tell me what I'm looking at. So, oh, here we have the smaller sunspots. They're about half the size of the Earth. So we have one over here. This one. And then the other one is not far away, it's there. So here we have a sunspot, here we have another one, and a little bit of a solar flare on the edge. So let's put it into grayscale. You see that the details are better, I think, in grayscale. Or the view is more detailed in grayscale than without with a color image. Anyway, I like. So still having a cold. Sorry about that. This is also very nice. I think I will capture that as well. But how? What would be a good? Maybe like this. So we see the chromosphere, we see two sunspots, and there's a little bit of flaring going on. So maybe I can put it a bit higher. Nah, that's not really what we want. Yeah, I have to choose between the flare. It's a very small one, so let's go for the sunspots. So let's take a 1 minute video again. So let's see. Am I still receiving your chats? Not speak English, SpongeBob. Well, are you talking about me or are you talking about you? AM5 already saw that message. What's the name of the telescope you're using? Yeah, I'm currently using the Photoline F6, so that's an 80mm telescope service, Photoline F6. It's about 500mm, but together with the chromosphere, like the Daystar chromosphere quark, you get about 2000mm of focal length. So we get this close-up image of the sun. It's still capturing, yes, and we got 2500 frames. That's pretty cool. Maybe stretch it again a bit. They are pretty active. All right, let's move on. So I'm happy to see that I paired the AM5 now with the control, the scope controls of SharpCap of that particular software. It seems to work really well. That's cool. So I think there are about 3-4 sunspots that are active today. Obviously, this is the brightest one. I'm going to take a couple of videos of the brightest part. Let's hope we see some eruption. Would be cool. Here, this is the area in color. So, 12:30. Is anyone having lunch? Yeah. I like this one. Should I put it in the middle? I think so, right? Let's use some crosshairs to focus the sunspot in the middle, or to put the sunspot in the middle. Go. Well, there are also the rest of that region. I think I put it a little bit on off center then. Maybe like this. But I also want to have the disk in the picture like this. And I also want to capture it in mono. So I'm going to take a couple of like performance sequence, maybe 3 videos, 3 1-minute videos, why not? Oh, I'm still, I don't want color. Because color you can always add it. I'm not capturing in color because first of all we are only looking at the very specific wavelength of the sun. So the red part of the light spectrum. And you can always add color in later when you're processing your picture. So that's why I'm not using color all the time to capture my videos of the sun. So here we go. capture sequence running. We also have this nice filament here. Yeah, you can definitely see this is an active region. So I think when we track it for like an hour or so, maybe we can see some eruptions or some changes in the structure of this particular area. That would be cool. Right. Yeah, I'm capturing about 2500 frames for every video with a FPS of about 45 per second. So what I will do is I will also process that those videos I'm taking right now, so you can get an idea of what kind of detail you can get when capturing the sun with this kind of setup. So let's first wait until these 3 videos are captured. Guys, you're pretty quiet. You still need a first coffee? 20 people watching. Hi, 20 people. We're looking at the sun, and this is the brightest sunspot area. It has a very interesting name. It's called 3234, and it's about 5-6 times the size of the Earth. So I'm capturing 3 videos here, and then I'm very sorry. I think my voice breaks down every time. I will process those videos so you can see a little bit what you can do with a backyard telescope and or a solar scope. Anyway, so this is the second one, I think. Let's try to see if we can detect little changes here. I don't think so, but so one remaining. This is the 3rd video I'm capturing. I'm also getting a coffee, and then I'll be back to capture this particular sunspot area to see what kind of details we can get from those videos. Right, so let me show you also colored version again. Now I'm going to go onto my rooftop to get my my hard disk and to process this area on my PC. Oh, here we go. Oh. I'm risking my life every time I go on that rooftop. I have this anyway. I should put a camera up there, I know, so I can show you what the telescope looks like and what camera I'm using. And no, I don't want the USB drive scan. Please stop. Yes, stop. Scan stopped. Can you see? You can't see it, I think. What are you looking at? You're looking at that particular picture. Yeah, I will keep this view. Or do you want me to show you the processing? So I took that that USB drive from my PC, and the black spots. Yeah, Dan asks, I wonder what the kind of temperature those black spots are. Yeah, a couple of thousand degrees still on the surface of the sun, but interestingly, those black sunspots are relatively cooler as compared to the brighter areas you see. So the blacker the picture is, the cooler the area of the sun you're looking at. So that's, at least I read somewhere that that's the case, and I think that's like that came from a pretty reliable source. Anyway, instead of my scope arriving yesterday, I got 5 inches of snow. Bob, feel for you, Bob, but they will arrive at one point, and then hopefully you will have clear skies to look at the night sky. So this is the coolest region, area 3234. So if you combine those numbers, you have my age. No, not really. So I'm 46 years old here. Oh my god, I'm getting old. And I have a weak knee, so every time I go up that ladder to my rooftop, it's kind of tricky. I need a more permanent solution. So yeah, I'm going to process that particular the image you see right now. I'm going to process that, so that will take a couple of minutes. I am PPG. If I can even find the right software. Let's see. So Bob, are you smiling at my age? Yeah. What kind of telescope did you order, Bob? Can you enlighten us? Enlighten us, please. IMP. I cannot find it. First of all, I need to find that program. I think I have like so many hard drives. It's on J, I think. So meanwhile, I'm just going to show you this sunspot region. I think that's pretty cool to see. Live view of that particular region of the sun that is most active today. So was it here? Yeah. Okay, IMPPG. Yep. So let's see if I can process some of these. So this will be very quick. Let's see the latest video here. Oh no, of course not. I first need to stack it. So auto staggered. Yeah, let's do that. Do you want to see my screen? Yeah. Could show you that. Don't know if it's interesting. My desktop. This is my desktop right now. Oh, bit of turbulence. Window capture. No. OBS, where are you? Display capture. My screen, but I have a little bit of a strange screen. You can see it here. Right, so this is my, hopefully when I click on this, you can see this. No, this. Let's not put that up. Can you now see the active sun on the front? I have to check it actually with my live stream. Live. Yeah, then oh no, I can't. Oh, I can do it on my smartphone, I think. My smartphone. So we have the Red Cat 71. Congrats, Bob. That will give you some nice wider field images of the night sky. I don't even know what you're talking about. Nah, I'm not. Okay. Hi. Oh, that's your name. Gaming Union. Welcome to the stream. You're looking at a live view of the sun, or more or less. Yeah, you can see this. Okay. Maybe I should keep it to... like this. I think if I put it like this, you can see most of what I'm doing, I guess. But then you can't see the live view. So let me just, this is just like this 1 minute video I took. I'm going to process it in a program called Auto Staggered. It will be the surface, yes, improved tracking, why not? Analyze. So here we go. Oh, it's slow, 5%, 6%. So let's show you this live view of the sun in the meanwhile. Is there any, do you see any bright solar flares like erupting yet? Not really, I think, but it's cool to see. There are little changes, I think. So if you watch carefully, you can see maybe some new sunspot area or sunspot areas getting bigger, or sometimes you have to be lucky. But I think like half a year ago when I just got this Daystar Quark solar filter, I saw an eruption that only lasted for about 5 minutes or something. I was lucky then. I think you need to stare at these spots for maybe an hour or two to really detect subtle changes. Approximately 4,000 to 4,500 degrees, yeah, in the umbra. So the umbra is the black part of the sunspot. So Astro Frank. And that's cooler than the rest of the sun we're looking at. So the brighter regions are hotter than the 4,000 you're quoting here, I think. Now, cool, Astro Frank. Thanks for helping us out. So I can continue processing. Here. 65%. Come on, auto staggered. I need a quicker desktop PC, I think. So sunspot 3234. This is the live view. The whole area is about 7 times, so 5 or 6 times the size of the Earth. And I think this also, the 3234 is here on the disk for, I think, almost, or like the disk facing the Earth for almost a week now. And I think this area also caused the coronal mass ejection and actually the northern lights, the aurora we were able to see a couple of days ago, 1 or 2 days ago. Anyway, auto stacker, did you do your job? Yeah, here we go. Oh, it's still analyzing. Okay, analyze away. So insane to see the black spot on the sun and to think that our entire Earth fits in that spot multiple times. Yeah, that's, of course, we have this illusion that the sun and the moon are about the same size, and the apparent size is about half a degree. So it's about the same size when we look at it from Earth, but yeah, of course, it's not a 3D perspective. So the sun is about 150 kilometers away, million kilometers away. 150 million kilometers away, and I think the moon is like 280,000 kilometers away. So here you go. So the sun is this massive object, and thanks to the sun we live here, huh? And we're here cozy, and it's warm enough to actually drink a cup of coffee. Let's see. Auto stacker, did you do your job? Still not. Yeah, it's a pretty big size. It's like 3,840 by 2,160 pixels. So the camera I'm using, it has a very small pixel size, and that's also causing, I think, I did have 2 times binning. So the video that I'm processing right now is 1420 by 1000 more or less. So it's not almost HD, but not quite. So yeah, and tonight we will have, of course, the Venus-Jupiter conjunction. I showed a conjunction yesterday live also, so if you're interested in that, you can check it out. I'm planning on looking at it again tonight, so if you're interested in the Jupiter-Venus conjunction, I hope it will fit the view I'm having right now with this camera-telescope combination. Yes, okay, so now we have a process, and it says that basically 25% is good quality. Let's check it out. Maybe I'll go like this. Should be the frames on the left. It organized the frames on the left as the highest quality frames, and the frames on the right the lowest quality. So this is apparently the highest quality frame I have in this video. So let's compare that to the weakest quality. Yeah, you can really see here this blurry picture. This is the worst frame in the video I took, and this is the best frame in the video I took. And then we can just see at what point we're not happy with the quality anymore. Mostly, I mostly take this 50% line here, the quality graph, if you can see it. And that's about like a little over 25% of all the frames, if I'm looking at this correctly. So 900 frames. So maybe I will stack only the 900. I will stack 1000 frames then. Now let's do that. 1000. 1000. Do I want sharpened? No, I don't want sharpened. I will use another program. Save in folder. Yeah, why not? Oh yeah, of course. Oh, let's zoom out again. I need to do some auto gridding. Place AP grid. Is that okay? Ooh, it's a bit. I will just use broad AP grid like this. Yeah, why not? Stack. Okay, so now it's going to stack the 1000 highest quality frames of that particular video to produce a picture of that sunspot area. Anyway, this is for the astrophotography nerds out there, or the solar and lunar imaging people. Sunspot 3234. How shall we call it? The Eye of Sauron. Looks a little bit like it. We have some nice here, I think also solar flares on the foreground. This, I like the black and white better, but Let me know. Grayscale or color? What do you prefer? Stacking is better. Like 80%, 90%. Can you see it? I think so. I can't check it. I think you can see it. It's still processing. Daan Klein. Oh, it's almost 1 o'clock. Do we have like the Meridian flip? So you see here, the sun is exactly in the southern sky right now. Can you see it? Here. So this is the highest point. But still, we have a lot of turbulence. I think it's maybe from my rooftop. I put my telescope on my rooftop, but my rooftop is also producing a lot of heat right now, I think. So that's why we see this shaky image. And also we just have the atmosphere, of course. We can see auto staggered. All right. Thank you, Dan. Oh, it's going slow. 70%. 71. 72. Oh, it's wobbling. We're also close to airport Schiphol. That's the biggest airport in the Netherlands, at least. So I have had it. We had it a couple of times, also during a live session, that a plane would go in front of the sun. Nope. No, that's not auto staggered. Oh, come on. Image stacking. Oh, it's now actually stacking. Okay. It is first thing it does is image alignment. Then it goes stacking. Okay. And then it will recombine. Okay. I'm curious what it comes up with. Should we move around again? I'm waiting for the stack to finish. Maybe this is the... Nah. Black and white. So I think the brightest spots are the lowest temperature, and the black spots are the highest temperature. So you can really see. So around the sunspot, there are a lot of hot areas of the sun. So I guess it's likely that the solar flares or some kind of eruption would occur around this area. Joof. Very cool. Okay, auto staggered. Where are you? 70, 89, almost done. Okay, let's fire up. Yeah, this one. Let's put it a bit here so you can see it. Hopefully you can see it like this. Hope. All right, it produced a stack, so let's check out that image. Her? Oh yeah, I took those pictures. Let's delete all the fits files. Fits here. This is what you get when you don't pay attention. Bye bye. Okay, and now look at the... So this is the picture it produced. Let's use that in IMPPG. Could be, okay, so we have like a bit of a vague picture. like a blurred picture of that area, but you can use IMPPG to stretch that particular picture. Why isn't it showing anything? Normally you would see the results of this. Now, of course, it doesn't work now. Why not? I don't know. Oh, here we are. Tone curve. You can have this area and then stretch that area. Here. This is what you can do. Yeah, still a little bit blurry, but reset, stretch. Still a bit blurry, but it's better than where we started. Maybe we should do only this. Can we then... So maybe to get more of a... So we stretch the histogram a bit to get more differences between the black and white area without overstretching. It's always a bit tricky to do. But we can do it like this. So apply to the whole area. So this would be like a processed picture. You see, it's a lot better than the live view we're getting, because we have now stacked. Oh no! Why didn't? Like this, more or less. So when you stack 1,000 pictures, you get this kind of detail. I'm going to actually save that. Save. What is it? Sunspot area, AR area 32, 34 or 30? Yeah, I think so. All right. Noise. Bob Henderson, how large would Mercury appear at this scale? Very small. So even if you have 2000 millimeter focal length, actually we had like you have to Google it, but a couple of years ago we had the Mercury transition in front of the sun. So Mercury moved in front of the sun, and then you can really see the difference between Mercury in size and the sun. So, for instance, this sunspot apparently is about 5 times the size of Earth. So Mercury would be like 4 or 5 times smaller than this particular area we're looking at right now. So pretty small. A small black dot moving in front of the sun. That's basically what Mercury looks like through a telescope. So yeah. Maybe take a final tour here. Oh. Ah. Yeah, I think I reached the Meridian. So my... yeah, okay. I need to go home now. I have to do the Meridian flip of my mount to get a view of the sun. Is it still? I can try to do it. So, how can I perform that Meridian flip? Let's try to get the view back. Here. Maybe I can best use... Oh. Hello. It's not responding. Close the camera. So where is actually the sun right now? Let's check it out. Major objects, okay. 22, 47, 17. 22, 47, 17. And the deck is the deck minus 07, 42, 11. 42, 11. Okay. And okay. Let's try to get the sun back. I need a mount. This is not so important. Let's try to recenter it. Okay, mount is slewing to the sun again, but I have this close up view of the sun right now, so I'm really curious if I'm able to find the sun again through my telescope, that is. Okay, the slewing is done. Okay, abort. Let's go back to sharp cap. Cameras rolling. No filter wheel, that's correct. Oh, it's not in the field of view. That's what I was afraid of. I can try to find it again. I do have some. I think here maybe. Oh, it's getting brighter. Still not. It's always tricky when you're zoomed in that much. Let's see. It's almost here. Oh, here we go, I think, hopefully. Is this it? Yeah, we're back. We are back. $300. Okay. We did the Meridian flip. Let's see. Now up is down. Here we have it. I think this is the most active region. Definitely. Can we swap it? Gain, frame rate, timestamps, Jeep. Image controls. I have to go further up, I think. I could flip the... Where is that? Here, flip. Horizon, horizontal, vertical. Both. Yeah, now it's on the same... this is actually the best view. Or the correct view. Oh. Let's go down. Okay, so that seems to work. That's cool to see. Still a lot of wobbling, unfortunately. So let me know Color or grayscale? Grayscale. I do like it. So if we stretch it live, we get this higher contrast view of the area. So the hottest places are lighting up right now. And yeah, where is that picture? I think I've seen about what I wanted to see. Oh, this is the picture. Oh, you can't see it. Could stretch it a little bit more, but my screen. Yeah. So I think you can see the picture now. It's not perfect, but it's okay. So these are 1000 frames stacked together, and we get this nice sunspot 3234 picture. So yeah, that's about what you can do with a solar scope, or yeah, like a Daystar chromosphere filter in combination with a telescope. All right, let's kill that. So yeah. No more questions. I think I'm going to also look at the Jupiter-Venus conjunction tonight. So if you're interested in that, I will try to catch it. I think about 6:30 my time. So about 7 o'clock at night. But I'm at like Central European time. So that would be somewhere in the afternoon for people in the US and after midnight in Asia. Anyhow, guys, thank you for looking at the sun with me, and hopefully I will see you tonight. Bye bye. Yes, done. I will be live streaming the conjunction.